Hi everyone, I'm Ludovico Caldara. I'm Senior Principal Product Manager working at Oracle in the Maximum Availability Architecture Product Management team. And I take care of Oracle DataGuard and Flashback technologies. Today we will talk about Oracle DataGuard and why it is the best product to protect your mission-critical data and all your databases. So when we talk about data protection, we want to protect our database from unexpected outages, from data loss. And the first thing that comes obvious in our mind is to have a replica of the data that can take over the primary database in case there is any outage on the primary side. So this is how DataGuard works. It replicates physically the primary database to a standby database where the data is aligned by redo stream. So all the physical modifications that are applied into the primary database blocks are replicated, streamed and replicated and applied to the standby database. And there might be, of course, one or more standby databases, but I would say that the typical configuration is one standby. Of course, if you want to have more databases, is more than possible. And sometimes we also recommend it as a best practice. Then DataGuard by itself would be an active passive solution where the standby database is not available for queries. And it stays there to give already good level of protection, but active DataGuard is the product that we add on top of DataGuard that improve the availability and improve the capabilities of the standby database by having, for example, the possibility to use the standby database as a read-only database so that you can offload, for example, your queries, but also add many additional features like, for example, automatic block repair. So additional protection that you only get if you enable active DataGuard. But we will see some of this feature later in this presentation. But I would like to tell many people think that Oracle DataGuard is an old technology because it's actually, I think, 20 years old, something like that. But being a stable and old technology doesn't mean there is something legacy, not at all. We are improving and perfecting DataGuard release after release. And just in this slide, I will not go through all those features, but it's just to give an example of how many features we introduce each release that help customer to have easier configuration, lower downtime, better protection, and really those are features that we introduce because customers have the best scenarios with really the most critical systems, the most critical workloads, and they always come with edge cases that we try to solve, and we solve those edge cases by adding those new features that make DataGuard better and better after every release. And I can say that we are already at the point where DataGuard, I would say, is perfect. Every release I say DataGuard is perfect, but then we keep adding incredible feature every release. And we will see a few of those features. Of course, it will not be possible to see all of them. But to come back at the basic of DataGuard, why we think that DataGuard is a better solution in general for data protection for the Oracle database. And in general, why log-based replication mechanisms are better than a storage replication? Well, because if you use a storage replication, and still we have many customers that prefer to use storage replication, and we disagree with that, with this architecture, is the storage replication has the primary volumes on storage on the primary side and mirrored volume on the standby side. And every single block that is modified on the primary storage is replicated entirely to the standby storage. So there are many problems with that. The first one and the most important is that there is no validation from the database. That means that if you have any, for example, corruption on the primary site, the same corruption will be replicated to the standby site as well. And because the standby side reside on mirrored volumes, those volumes are not usable, so the standby database cannot run in any way, and it's not possible to verify that the copy is corrupted until we try to recover. And we will see that if the primary failed, we have no standby because the primary was corrupted and the standby was also corrupted. So this is a problem, this lack of validation, but also all the blocks that are in the data files, in the temp files, log files, and control files, all the blocks are replicated. And that makes the whole process quite inefficient because there is much more bandwidth needed for that. And also the network IO required is much bigger. That means that you have any ingress or egress cost if you are, for example, in a cloud provider. Using storage-based replication will also affect the cost of the solution in general. DataGuard, on the other side, is optimized for the replication of the database. And only the modifications to the block, not the block themselves, but only the modifications to the block are stored as change vectors inside the redo stream. And this redo stream is transported to the standby database where it is verified and applied by the database itself. So if there is any problem with the checksum of the blocks, if there is any corruption problem, DataGuard can detect and, eventually stop if we are at DataGuard, but we will see that it's also possible to fix the problem automatically if you use active DataGuard. And this is absolutely efficient and give a basic protection against, for example, ransomware attack if it's something that we are careful about. And when we advertise DataGuard, we say that you cannot have data loss. And this is a big, is a big statement, is a bold statement. Not having data loss, how can we ensure that there is no data loss? Well, first I need to explain what happened when you have a primary database and a standby replication, and why this is problematic to guarantee no data loss. When I have a standby database that got disconnected from the primary site, and imagine that I don't have access anymore to the primary site, I completely lost my primary site. I only have my standby database and I need to fail over to it. And the first question that I have, how much data loss do I have? If I fail over now to the standby database, will I lose any transaction? How many transactions? So many customers say, okay, I will just check when the primary disconnected from the standby database and assume that that time frame is the data loss that I'm losing. But that might be not accurate for many reasons. Also, we might want to check up to which point the standby can recover. So imagine that 5 minutes ago, I've lost my connection to the primary database. The primary is not reachable anymore. And I can check inside the standby log of the standby database, so where these change vectors are stored, what was the last timestamp that has been registered, so that I know that I can recover up to that point. But still, I cannot have the proper idea of how much data I'm losing if I do a failover. Why? Because I don't know if the primary crashed, if it stalled, or if it kept committing for any reason. So imagine that I lost connectivity with my primary, but for some seconds or some minutes, or perhaps still now, the primary is still active and committing data coming from some application. But I cannot tell it because I cannot reach the primary anymore. So this is a problem where just by having a primary and a standby database, it's impossible to determine if there is any data loss. So what is the solution? We use fast start failover for that. Fast start failover is a configuration where we introduce an additional element in the DataGuard configuration that is the observer. So the main duty of the observer is to verify the configuration, and whenever the primary database is not available, it does an automatic failover to the standby database. And there are many customers that think that it is dangerous because they prefer to have the control over when the failover is done. But this configuration has big advantage comparing to doing manual configuration is that this configuration knows that there is no data loss. And I explain why. The observer acts as a quorum in this configuration. That means that, for example, if the primary and observer lose the connectivity to the standby site, the primary knows that the standby is not available, but knows that the observer is still connected to the primary. So the primary knows that it can keep committing without the standby database and knows that there is no split brain. So there cannot be a condition where the observer fails over to the secondary site because the secondary site is not available. So the primary has this notion of having a quorum on its side. If I lose the observer, well, the primary will still see the standby site and will keep replicating the data to the standby site. And the observer in that case, well, it will not be part of the game anymore. But you can still have multiple observers, for example, to give a high availability solution to the observer. But if the primary lose the connectivity with the observer and the secondary site, this is a configuration where the observer will do a failover to the standby site. But what the primary will do at this point, it will try to keep sending the information, the transaction information to the standby site. But because the standby is not reachable, it will stall and will ask to the observer to keep writing with the observer permission. But because the observer is not reachable by the primary will just stop accepting transaction and will shut down. So depending on the configuration, if it's synchronous or asynchronous, we can guarantee that the primary does not commit a single transaction. So it does not lose any single transaction if the observer and the standby database are not reachable anymore. And this is how we ensure that there is a failover without data loss. And this is something that is not possible to ensure if you don't have an observer that gives this quorum to the primary database. And you can configure fast start failover with 3 different protection modes. The protection modes is a way in which we can control how much data loss we can tolerate. Because if we transport our data synchronously, we will have no data loss. But in case we have any problem with the standby database, the primary will stall on the network connectivity, trying to send the data synchronously to the standby database. So we have a first protection mode that is maximum performance, that says sends the data asynchronously. I tolerate some data loss, but I don't want the primary to wait. Maybe because I have too much latency or the workload of my primary database is so high that I cannot tolerate a synchronous replication. So I have the choice to tolerate a data loss, and I can also control how much data loss I can tolerate. Then I have the maximum availability protection, where the primary will try to be synchronous with the standby database. But in case the standby database is not reachable, well, if the primary still has connectivity with the observer, we'll keep writing without protection. And so the primary will be temporarily unprotected. And then there is the maximum protection mode, where it doesn't matter what, if the primary cannot commit the information and replicate the information to at least one standby, it will freeze. It will stall until one standby is available. Okay, and this is a configuration where we always recommend to have at least 2 standby databases so that you can do maintenance on one standby database while the other is keeping the primary database protected with synchronous replication. So you have the choice among those configurations. And it's really important, again, that you consider fast start failover as a 3-member configuration with the primary, the standby, or 1 or more standbys, and the observer, and the primary really having the quorum together with the observer to be able to keep committing and not losing any transaction. So DataGuard is a solution that we sell mostly for data protection, but it's not just a data protection or disaster recovery solution. There are many other things that you can achieve with Active DataGuard. Well, the first one is some advanced data protection that is not always obvious, but there are many features related to data protection that Active Data Guard gives on top of Data Guard. We can use it for data migration, for example, using Data Guard, setting up a standby on another server and then doing the switchover. This is something that we use, for example, with zero downtime migration to migrate databases in the cloud, but customers have used Data Guard for database migration for many, many years. I did it also many, many times in the past. But you can use it also for scale out and testing or rolling upgrade. So let's have just an overview of a few features that you get if you have Active Data Guard. For example, for scale out testing and scalability, you can use real-time query. Real-time query is probably the most prominent feature in Active Data Guard that most of the customers know, is that you can enable the standby database, you can open the standby database read-write so that you can query actively on the standby database. And you can use it, for example, to offload the reporting or offloading the ETL extraction to the data warehouse from the standby database so that you don't load with the primary database. But if you architect the application properly, you can also have a connection to the read-write primary database and have the read-only connection going to one or more standby database. You might also have a farm or read-only standby databases where you offload your read-only traffic. So that is that give a very efficient scale-out solution for your read-only traffic. But also thanks to the DML redirection, you can also do occasional writes on the standby database. That means that even if your standby database is read-only, you can activate the functionality that redirects all the DMLs to the primary database, and those transactions are executed on the primary database and replicated back to the standby database. So it gives you the experience of an ACID transaction executed on the standby database. We have automatic block repair. Imagine that you have one block that gets corrupted on the primary database for any reason. Well, as soon as a user session detects that there is a corruption on the block, it will request a good copy of that block to the standby database and repair the block automatically. And the application, the user session, will not experience any error because the repair of the block happen automatically underneath. So you will just see the entries in the alert log, but the repair is done automatically. So there are many customers that don't even realize that they have the blocks protected and fixed by this feature. It's just because it's completely transparent. Another feature that is really cool in Active Data Guard is the online rolling upgrades that customers use mainly for major upgrades, because the major upgrade, for example, from 12 to 19C, are upgrades that usually require several hours of downtime. Using the online rolling upgrades or the DBMS rolling package, that is the package that is used underneath, you can take your physical standby database and convert it to a transit logical standby database and update the logical standby database while the user still accesses the primary database. And the standby database is aligned not anymore by redo apply, by applying the change vectors, but by mining the log information and converting those changes into SQL applies that are applied directly on the logical standby. So you can very well stop the logical apply, upgrade your logical standby, and start the apply again. And you will have this logical replication going from the primary in 12C, for example, to the standby in 19C. And when everything is aligned again, you can just switch over, and the downtime experienced by the application is really negligible. Sometimes it's really in the seconds instead of the several hours. And we are planning to make it better. So we are planning to introduce more features and capabilities to the switchover phase so that the application does not experience any outage. You can also have, for example, fast incremental backups on the standby database. You can leverage the block change tracking capabilities that you have to take fast incremental backups and have this block change tracking mechanism on the standby database, so that if you offload the database on the standby, you have much faster incremental backups. And you can use, for example, FarSync, always in Active Data Guard. FarSync is a technology that allows you to have synchronous protection, so no data loss protection for your primary database while your standby database is far away. So imagine that you have inter-region protection standby database. You just have to put a FarSync instance that protects your primary database nearby the primary database, but not in the same data center. The reader is transferred to this FarSync instance synchronously, and it is redirected asynchronously to the standby side. So the primary database does not suffer from the latency of having a standby database that is far away, but still is protected by the FarSync instance. And of course, the last one that is, for me, the best feature that you get with Active Data Guard or with Real Application Cluster, actually you can get this feature with both of them, is application continuity, where an application can use a special client configuration so that if there is any outage of the database at the driver level, the client reconnects, validates the transaction, and replay the transaction. And this is quite unique because in no other cases you can have a commit that has already been issued by the application, but you don't know what's the outcome if the database stops just at a time. So imagine right now I try to commit, but the primary database crashes and I don't know if the database is committed or not. With application continuity, the driver can check if the transaction that I started at the client level has been committed or not, and decide if it's the case to replay the transaction automatically or not. So this is really transparent for the application, and it's absolutely unique feature. Now, we have Data Guard for the on-premises databases. We have Data Guard also for the cloud. But depending on the cloud service that you choose, you can have a variant of Data Guard. But let's say that, for example, the Exadata database cloud services, they have a full Data Guard that has all the features that we have seen and more. The database had Oracle-based cloud service has the same Data Guard. But then we have the autonomous database, and there are two variants of autonomous database. We have an autonomous database on dedicated Exadata infrastructure. That one is, if you have dedicated infrastructure, you have a full container database where you have the control of the different PDPs, and you have the protection at the CDB level. So whatever pluggable database you create, whatever autonomous database you create on a dedicated infrastructure is protected automatically because it belongs to a container database that is protected by Data Guard. Okay, so you get the same protection. Recently, we have introduced fast start failover also for autonomous database on dedicated infrastructure. But then we also have autonomous database on the shared infrastructure, and they use a different technology underneath that is 100% automated. So the very cool part of autonomous databases, there is a service that you can spin up using APIs via command line, or just with a few clicks using the Cloud Console, the Cloud Console. And you can protect this autonomous database, again, with a single click, again, from the console, or with a single API command or a single command line. And you can decide where you want to put the replica of this autonomous database. So you can have a replica locally, you can have a replica remotely in another region, or you can have both. So this is the only case in the cloud where out of the box you can choose to have two replicas, local and in a remote region, and it's 100% automated. So you don't really have to do anything else, and we take care of everything for you. But because it's a pluggable database, the autonomous database, that in an environment that you don't control, because it's a cloud service that we provide all the management for you, but it's a pluggable database that doesn't have replication via redo stream using the traditional data guard environment. So it uses a log shipping that is sent from the primary autonomous database remotely to the standby databases. So it does not have the same RPO, the recovery point objective, as the traditional data guard, but it might have an RPO up to 1 minute. So it really depends between 0 and 1 minute. But the cool part is that it's absolutely 100% automated, and you don't need to care of any configuration whatsoever. Now, talking about pluggable databases and what we have today with multi-tenant architecture, we have the data guard protection at the CDB level, and for PDB level protection, we have other mechanisms like the freshable PDB clones. Well, we have introduced it in 21.7, so last July 2022, we have introduced DataGuard for pluggable database. And this is a re-architecture of DataGuard that works best for the multi-tenant architecture in case you want to have protection at the PDB level. So what you can achieve with this new feature, you can have a primary database with the source PDB and only have that source PDB protected in a remote primary CDB. Okay, so now we have two CDBs that can contain primary PDBs that are open read-write, and have target PDBs that protect the source PDBs of each other. So you might have, for example, in a primary PDB, you can have PDBs that are either source PDBs protected by another CDB, or they can have target PDBs that protect the other CDB, or they can also have non-protected CDB like we see in the slide. Now, it's a very new release, and it's a major architecture of the DataGuard architecture and code. So it's still in early phases. So there are some limitations with that. And the plan is that release by release, we will improve this new architecture by filling all the gaps that we have with the traditional DataGuard. But imagine that the traditional DataGuard is something that we have developed for 20 more years, and we had all the times to add so many features. And now we are just in the first release of DataGuard per pluggable database. So it is normal that we have some gaps that we still need to fix. There will be some gaps that will be fixed already in 23C, but still there will be some other limitations that will not be fixed in 23C, and we'll have to wait for future releases. But the major limitations are, for example, that you cannot have synchronous performance as of today, synchronous replication or max availability in the standby database. You cannot have fast start failover. You can have just two CDBs in the configuration. Of course, you can protect as many PDBs as you want, but just two CDBs in the configuration as of today, and active data guard. And I think I can already tell that active data guard will be one of the first limitations that we will fix in 23C. We will have at least try to have real-time query available in 23C. But this is something that will probably happen, but please don't I don't have my safe harbor statement here, but that is something that we expect to happen. And talking about the architecture, what you have primary, you have two primary CDBs, as I said, because in both CDBs you can have a database open read-write. And at the transport level, you have all the redo stream that is sent by the transport process to the remote CDB. And there it's written into the standby redo log. So the process does not change much until this point. But then you have one apply process per PDB. So if you have one standby PDB, you will have one apply process. If you have 10 standby PDBs, you will have 10 apply processes that get information from the standby redo log and apply only the redo information that applies to those PDBs. And of course, you will have synchronous processes the other way around, from New York to Boston in this case, in this slide. So stay tuned, because there will be more news about the GPDB, but in general, also in 23C, we will see that there are more information, more features coming. And that's all from my side. Thank you very much for joining this session. And I hope you find this information useful, interesting. Feel free to keep in touch with me. You can contact me. You can see my email address, ludovico.caldara@oracle.com, if you want more information. And I wish you a good rest of the day. Thank you very much.